Hey, I'm Bill, and today I'm going to go over Teradici's single IP Azure deployment architectures that have recently become available over in our public GitHub repo. So the single IP deployments have one public IP that's directly available, as the name of the deployment implies, and this is in contrast with the traditional non-single IP deployments, which have public IPs assigned to several resources, including the cloud access connectors, the CAS managers, the domain controller, and sometimes even the workstations as well. So in the single IP deployments, there's only a single public IP that's directly available, and this will be the IP that you connect to through the PC over IP client to initiate the connection. So now, just because only one IP is directly available doesn't mean that this is the only public IP that the PC over IP client will communicate with. It's just that rather than having other public IPs be unnecessarily exposed, only the addresses and the ports necessary to create a PC over IP connection are made available to communicate with. So this is made possible through network address translation, abbreviated as NAT, N-A-T, that's configured in the load balancer to reach the necessary private resources such as the cloud access connectors and CAS managers. So what this means is that the underlying resources have a lot less direct public exposure, since each IP address and port is configured to only allow connections of that certain type through, and that the deployment creates the minimal amount of public IPs and NAT rules necessary for operation. The great thing about this is that despite these added changes to the underlying architecture, the deployment process and the functionality of the PC over IP works essentially the same, so you don't need to worry about having to change anything. There are a few changes you can make to the deployment after it's finished to remove some unnecessary rules for debugging purposes, but they aren't necessary at all if all you're looking at is to get a working deployment. So there's a couple of different variations on the available single IP deployments. So as you can see here, there's 4 listed in total. There's single IP deployments that use the load balancer and traffic manager deployment with CAS manager as a service, and there's also a single IP load balancer and traffic manager deployment that makes use of CASM all-in-one deployment, as well as the AADDS and Azure Active Directory. So AADDS stands for Azure Active Directory Domain Services, and that's a whole separate topic. If you're interested in that, we also have a video on that that you can check out. So architecture-wise, the 4 deployments are all relatively similar. The CAS Manager as a service deployment will also deploy a domain controller instead of using the AADDS. And the traffic manager deployments deploy a traffic manager that connects to the front end of the load balancer, and users will connect to the traffic manager domain name instead of the public IP of the load balancer directly. So shown here is also the architecture for the load balancer single IP deployment with CASM and AADDS, which shows a bit of what happens during a connection. So the PC over IP client initiates a connection with the load balancer, and the load balancer connects to the cloud access connectors, which initiate a PC over IP connection on port 4172 with the client. So all these other private resources don't have public IPs directly attached to them and communicate only through the load balancer NAT configuration. So here are the actual deployment steps. The only requirements that you'll need are an active Azure subscription and a PC over IP registration code. You'll then need to fill out some credentials and variables before deploying, and then configure workstations for the actual PC over IP connection. So I won't go into more detail on this part since I'm going to demo it right after this, but this should cover the very basics. So that about wraps up the presentation section, and I'll be back in the next part where I'll go over a demo of the actual deployment itself. Alright, so I'm here on the Azure portal homepage, and I'm going to do the entire Terraform deployment in what's called the Azure Cloud Shell, which you can open here. The Azure Cloud Shell is just a shell-like environment that has all the dependencies that we need already installed, so it's nice in that we don't need to do any extra setup or anything like that. So if I list everything in the current Cloud Shell, you can see there's nothing really in it. So we're starting from scratch, and it'll be a fresh deployment. So step number one is to go to the Azure deployments repo on our public GitHub, and you want to clone this repo by doing git clone and now you should have an Azure deployments folder. And now you want to switch directories into the deployment that you want, which for us will be the 1IP load balancer deployment. So listing all the files in this folder, there's a Terraform main script itself, but the file that we're currently interested in is the terraform.tfvars.sample file. So this is a file that describes to Terraform what we're deploying and what we want. So step number one is to actually rename the sample file in the actual tfvars file. And now you want to open terraform.tfvars. So make this a bit bigger. So these are the variables that we need to set. The first few variables describe the workstations that we want to deploy. So the top two are Linux and Windows standard VMs, so they're not graphics hosts. The count specifies how many workstations of this type we want to deploy, and the other parameters are relatively self-explanatory. The bottom two are graphics, Linux, and Windows virtual machines, so we don't actually want any in this demo at least. So I'll set those to 0. And next up is a CAC location list. So the Cloud Access Connector location list will specify the location where the Cloud Access connectors will be deployed, obviously. The thing is, we want this region to match our region where the workstations are set. So right now you can see they're set to the same thing, West US 2, West US 2. The CAC count list is just the number of CACs that we want to deploy in each region, so I'll just leave this at 2. There's a lot of optional variables that I won't bother filling out, just keep things simple. For the prefix, I'll just call it demo. Alright, so all of those are optional. The next thing we need to fill out is the passwords. So these 3 passwords describe the passwords for the various resources that you'll need to log in with after deployment. So just set them to something secure. There's a couple of requirements for the passwords. It has to have 1 uppercase letter, 1 lowercase letter, 1 special character, and 1 number. So I'll just set mine to be demo password 1, demo password 1. Next up is the PC over IP registration code. If you don't already have one, you can receive one from our sales team. But I have one I can use here, which I'll just grab quickly. Alright, so the final 2 variables that we need to fill out are the application ID and the AAD client secret. So these variables relate to what's called a service principal, which is basically a managed identity that we'll use for the purposes of this deployment. So to create a service principal, you want to go to app registrations and then create a new registration. So if you already have one, you can use an existing one, but just to demonstrate the process, I'll create a new service principal. So 1 IP demo and register. So right off the bat, you can see the application ID is created for us, so you can just copy that in. And to create the secret, you want to create a new client secret, demo secret. And you want to keep in mind that this is it's a secret value and you can only see this once, so make sure to keep it in a secure, safe location. Copy that in. So that should be about all the variables that we need to fill out. There's just one more thing that we need to do, which is to set the permissions of the service principal. And to set these permissions, you want to go to access control and add. So you can add role assignments to the service principal that we just created, and there's 3 that we want to add. So we want to add the reader role, the contributor role, and the virtual machine contributor role. So let's start off with the reader role. Demo. So this is the service principal that we just created, if you remember the name. We'll click save. So it's reader added. Contributor. Finally, virtual machine contributor. Save. Alright, so that's all the variables filled out and all of the permissions that we need to set completed. So now we just want to begin the actual deployment. So to do this, in the same folder, you want to type terraform init. Just close. And it looks like everything's completed. So now that it's completed, you can just type terraform apply auto approve, and this whole process can take 30 to 40 minutes. So make sure that you don't close anything or stop the deployment while it's going. But for the purpose of this video, I'll just cut it off here and I'll start back up after it's finished. So I'll see you then. Alright, I'm back and it looks like everything finished provisioning successfully. So I'm just here in the resource group of the resources that were provisioned. So by default, the resource group name will be CAS Manager LBNAT followed by some random 6-digit hex code. So just looking through the resources, it looks like everything finished provisioning successfully. All the resources are there, the workstations are there, and everything looks good. So getting into the config a little bit, the main connectivity, as I said before, comes from the load balancer rules. So as you can see, there's a lot of IPs that are connected to the load balancer rather than to the actual resource directly. And there's also some inbound NAT rules to help external IPs be able to reach those private addresses when they need to. So you don't need to worry about this for the most part, but if you do want your, let's say, your resources a bit more locked down, there are a couple of rules you can remove. So if you want to remove some rules, you can remove the first one, so you no longer need this since it's just for uploading scripts to the domain controller during the provisioning process, and you also don't need the bottom 2. So to remove them, all you need to do is click delete, and it can take a while. I won't remove all of them, but if you want, the option's there. But that's about all I wanted to go over for the actual config of the provisioned resources themselves. I want to go into how to actually connect to the workstations now. So to connect to the workstations, you first need to assign users to the workstations by going to the public IP of the CAS Manager address from the web browser. So you just want to connect here, make sure you have HTTPS at the start, and proceed. So log in with the username admin user by default and the password that you set in the previous step. So you can have a look, the connectors. It says unhealthy, but it can sometimes just take a while to update. To actually assign workstations, you can add existing remote workstation, private cloud. You want to assign these two workstations and individually select users. So you can assign this user. And it can sometimes take a minute, but it usually happens pretty quick. So now that that's set up, to actually connect the workstations, you want to go back to the resource group and find the public IP of the main load balancer. So you want to copy this load balancer front end IP address, which is 20.80.142.182 to the PC over IP client. So I'll make a new connection here. Just copy this. And next. Alright, casadmin, and once again the password that you set. And log in. You can see these two virtual machines already, so I'll just connect the Windows virtual machine. Can sometimes take a while to connect, but it should happen eventually. It's usually just first time setup that takes a while, so the screen's black, but as you can see, stuff's setting up and we should be all connected soon. So that's about all I wanted to present in this presentation. Hopefully you now have a better idea of how to deploy PC over IP workstations and get them working, as well as the necessary configurations to actually connect to the workstations themselves. So thanks for watching, and I'll see you next time.